Topic 3D4, Law of Sine and Cosine. So the Pythagorean theorem, trigonometric ratios, and special right triangles all work when we're talking about right triangles. But a lot of times triangles aren't right triangles, in which case we have the law of sine and cosine. All right. For the law of sine and cosine, it is customary for angles to be labeled with a capital letter and side lengths to be labeled with lowercase letters. It is also customary for their angles and their corresponding sides to use the same letter. So angle C has a corresponding opposite side, lowercase c. In the same way, capital A and lowercase a go together, and capital B and lowercase b go together. Okay. When we're using the sine rule, it is useful in two circumstances. Circumstance number one, you have two angles and one of the opposite sides, or you have two sides and one of the opposite angles, right? And you can use A over sine A equals B over sine B equals C over sine C, or the signs can be on top and the side lengths can be on bottom. The law of cosine is useful in two circumstances as well. If you're given one angle C, then the two adjacent sides are A and B. Then you're looking for side C that is opposite to angle C. Or when you have the value of all of the sides and you're looking for one of the angle measures, A, B, or C, you can use the cosine rule, right? And these are the cosine formulas that will be provided for you. If you're looking for a side length, you should use the A squared version. If you're looking for an angle measure, then you should use a cosine C. Okay, so here is a flow chart for triangles in determining what method you should use. All right, if it is a right triangle, right, then you have to consider, are you given two sides? If you're given two sides and you're looking for a third side, use the Pythagorean theorem. If you're given two sides looking for an angle, you should use your inverse trigonometric ratios. If you're not given two sides, then you should use the trigonometric ratios to find one of those side lengths. If it is not a right triangle, can you draw a right triangle from it? If yes, then create your right triangle and then do your right triangle methods. If not, and the question involves two sides and two angles, you should think about your sine rule. If it involves three sides and an angle, you should think about your cosine rule. Okay, these are just guidelines to help kind of guide your thought process in what method makes the most sense going forward. So here's our first teacher example. We have triangle ABC and we're looking for side B. Right off the bat, what I notice is that we're given a pair of corresponding angle sides. So right here, this 7 and this 30 degrees go together, right? So if we're labeling it with capital letters, we can say this side length is lowercase a and the 30-degree angle is capital A. They go together. Similarly, the B that we are looking for has an angle measure that's provided of 70 degrees. They also go together. So lowercase b can go with capital B for the angle there. Since we have one known pair and one that we are looking for, we can use our law of sine. So B and sine of 70 equals 7 sine of 30. And then we set up our proportion, and then we're going to cross multiply. 7 sine 70 equals B sine 30. Divide on both sides. And when you put all of this into the calculator, B equals 13.2 units. All right, we just need to take a second. Does that approximately make sense? Yeah. The 30-degree angle should have a smaller corresponding side than the 70-degree angle. So 13 is a larger number than 7, so that makes sense. In triangle DEF, DF is 7, DE is 6 centimeters. And now we're looking for the measure of angle F if we're given DEF is 124. So similarly, we can see that we are given a corresponding side and angle. All right, since those go together And what we're looking for is another pair of corresponding side and angles. We can again use the law of sine, but this time to find an angle measure. So we'll set it up similarly. We know that 6 goes with sine of, let me start by labeling our given information. This can be our side A can go with angle A, and then side B can go with angle B. So 6 goes with sine of B, which is what we'll be looking for, is equal to 7 over sine of 124. And again, we're going to cross multiply. 6 sine 124 equals 7 sine B. And then this time I'm going to divide by 7 across the board, and I'll find that sine of B will equal, give me 1 second, 0.71. And since I need to get B by itself, I'm going to use inverse sine. So then I get B is equal to inverse sine of B, which equals 45.3 degrees. Okay. Try the student examples on your own. Now, teacher example number 2, we have triangle ABC that's not drawn to scale, and we're looking for A. Now here what you'll find is even though we're given a pair A and angle A, we don't know like a corresponding angle and side, right? But we are given 2 sides and its interior angle, right? So we have angle 37, and then adjacent to it, we have 5 centimeters here and 6 centimeters here, right? So when you're given 2 sides and then the angle in between, it's a pretty good sign to use our law of cosine. So we need to label. Since we're looking for side A, that A has to be the A squared in our equation, okay? So that's gonna be our A, which makes 37 angle A. Now sometimes the naming of the triangle will go against how you have to name it in order to make your equation work. That's okay, right? We are looking for A because that's the side we're looking for, not because of how it was already previously named. Knowing that, B and C don't matter quite as much, so I can have this one be side B and angle B, side C and angle C. And then we're gonna use our A squared equals B squared plus C squared minus 2AB cosine of A. We're plugging this in. We don't know what A squared is, but we know that B is 5, C is 6 minus 2 times 5 times 6, cosine of A, which is 37 degrees. And then when you put all of that through the calculator, we get A squared is equal to 13.08, in which case we need to find the square root of both sides, and A equals 3.6 units, in this case centimeters. Okay. And in triangle ABC below, find the size of angle ABC. So now we're looking for this angle here, right? And the way that our law of cosine is written, cosine of C equals A squared plus B squared minus C squared over 2AB, which means the angle that we are looking for has to be named angle C. So then this will be side C, and then side A, angle A, side B, angle B. All right, and again, you'll notice here that some of our angle names that we're giving it versus what it was previously given contradict each other just a little bit, because the angle that we're looking for is angle B, but we have to name it angle C while we plug it into our law of cosine. So cosine of C, we don't know what the C is, but we know a is 18, so squared, plus 22 squared minus 16 squared all over 2 times a is 18 and b, which is 22. Okay? And when we plug all of that into the calculator, 18 squared plus 22 squared minus 16 squared over 2 times 18 times 22, we get 23 over 33. So cosine of c equals 23 over 33. In order to get c by itself, we need to take the inverse cosine. So c by itself, inverse cosine equals 45.8 degrees. Okay. Go ahead and try student examples number 2 as well.